Hi everyone, welcome to the 5th lesson of pre-algebra. Last time we learned about different exponents and how to use them in PEMDAS. Today we're going to be moving on to a new lesson with variables. So I'm going to be talking about what variables are and how to evaluate them in expressions and equations. So to start off, variables are just another way to replace numerical values in some sort of expression or equation. So you've seen numerical equations like 3 plus 2 equals 5. Variables just replace the number to make things simpler. So this could be rewritten as 3 plus a equals 5. In this case, the a is written in place of the 2, and we would call a the variable. Variables are usually any sort of letter from the alphabet, and the most common variable is x or y. So to start off, we're going to be talking about how to evaluate variables in expressions. So for example, if you had an expression like x plus 4, the unknown value here is x, and that's what we call the variable. So there's different ways to evaluate this. The most common way is that a problem gives you some sort of number for x, and then you plug in that number and solve it. So if I say that x equals 3, then we would plug in 3 for x, and so the new equation would be 3 plus 4. Which is equal to 7. We're going to try doing this with a lot of different numbers. So with this, we're going to continue working with this expression, and let's try plugging in x equals 5. So if x equals 5, then we do 5 plus 4, which is equal to 9. Let's try if x equals 1. If x equals 1, we replace x with 1, and then we do 1 plus 4, which is equal to 5. Now what if the problem asks you to plug in a different number that's way larger, like 19? So the problem would say something like, evaluate the expression if x equals 19. So then you would plug in 19 for x, and 19 plus 4 is equal to 23. And that would be your answer. Let's do an expression with subtraction. So if the expression is x minus 2, and the problem says to evaluate the expression when x equals 3, then you would plug in 3 for x, which is 3 minus 2, and that equals 1. For the sake of consistency, I'm going to be using the same values for x. So what if x equals 5? Then we would do 5 minus 2, and 5 minus 2 is equal to 3. Our next number was x equals 1. So we would do 1 minus 2, and this time the result would be a negative number, so negative 1. And lastly, if x equals 19, we'd plug in 19 for x and do 19 minus 2, which is equal to 17. Now let's try an expression with multiplication. So how about 3x? Now we learned in a previous lesson that there's many different ways to express multiplication. For example, parentheses, a multiplication sign, a dot, but in this case, this also means multiplication because the variable is right next to the number. If there's no sign in between these two different values, that means that it is multiplication. So this is another way of writing 3 times x, or 3 times x. But for the sake of confusion, we don't really use this symbol with variables because it resembles an x. So let's try 3x with x equals 3. So if x equals 3, we're going to replace the x with the 3, and 3 times 3 is equal to 9. Let's do x equals 5. So 3, and then replace the x with 5. And so we would be doing 3 times 5, which is equal to 15. Our next number is x equals 1. 3 times 1 is simply 3. And then finally, we're going to do x equals 19. And so we do 3 times 19. And you probably don't know this from the back of your head. So let's solve it out. 3 times 19. So we do 9 times 3, which is equal to 27. And then 1 times 3, which is equal to 3. Add the 2, and that equals 57. So our answer here is 57. Now let's try combining more than one operation. So 2x plus 1. As you can see here, we have both multiplication and addition, but that doesn't change anything. Let's start with x equals 3 again. So we first plug in the 3 for the x. So it would be 2 times 3 plus 1. And we learned in PEMDAS that we do the multiplication first. So 2 times 3 is equal to 6, plus 1 is equal to 7. Let's do the same for x equals 5. So we plug in x for 5, and then add 1. So 2 times 5 is equal to 10, and 10 plus 1 is 11. Let's do x equals 1. So we first replace the x with 1, and then we do the multiplication. So 2 times 1 is equal to 2, plus 1 is equal to 3. And then finally we have x equals 19. So we plug in 19 for x, so it'd be 2 times 19 plus 1. And then we do 2 times 19 first. And 2 times 19 is 38. And then plus 1 is equal to 39. It's not too bad, right? Okay, now we're going to move on to something a little bit more challenging, which is evaluating expressions with two variables. So, what if we had an expression like x plus y minus 2? Well, we can't evaluate this unless the numbers are given. So, let's say x is equal to 2 and y is equal to 7. So we have to replace the variables with its values. So 2 for x and 7 for y. So that would be 2 plus 7 minus 2. And since we just have subtraction and addition in this expression, we just simply go from left to right. So 2 plus 7 is equal to 9, and 9 minus 2 is 7. Let's do that again with a set of different numbers. So x plus y minus 2 for when x is equal to 9 and y is equal to 5. So we would do 9 for x and 5 for y. So that would be 9 plus 5 minus 2. 9 plus 5 is equal to 14, and then minus 2 is 12. So our answer here is 12. Let's do the same expression, but with a set of different values. So x is equal to 11, and y is equal to 3. We would do 11 plus 3 minus 2. 11 plus 3 is 14, minus 2 is 12. So we get 12 again for this expression as well. Let's try a different expression like 3x plus 4y. So this time we have multiplication on two different variables. So this is actually the same thing as 3 times x plus 4 times y. Let's evaluate this with the same set of numbers as before. So x is equal to 2 and y is equal to 7. So we would plug in 2 for x and 7 for y. 3 times 2 is 6, and then 4 times 7 is 28, and 6 plus 28 is 34. So that is our answer. We're going to reuse that expression for a different set of numbers. So let's evaluate this expression for when x equals 9 and y equals 5. So 3 times 9 plus 4 times 5. And according to PEMDAS, we always do the multiplication first. So 3 times 9 is equal to 27, and 4 times 5 is 20. So 27 plus 20 is equal to 47. And that's our final answer. And our last set of numbers was x equals 11 and y equals 3. So we do 3 times 11 plus 4 times 3. 3 times 11 is 33, and 4 times 3 is 12. 33 plus 12 is 45. And that is our answer. Let's try one last expression before moving on to equations. So 2x minus y plus 6. For when x equals 2 and y equals 7. So, as always, we plug in the variable values first. So 2 times 2 minus 7 plus 6. I'm just using parentheses here to show where I'm plugging in the variables. So 2 times 2 is 4 minus 7 plus 6. And we just go from left to right. So 4 minus 7 is negative 3 plus 6 is equal to 3. And we're going to do the same expression once again with the second set of numbers, which was x equals 9 and y equals 5. So 2 times 9 minus 5 plus 6. So 2 times 9 is equal to 18 minus 5 plus 6. 18 minus 5 is 13, and plus 6 is 19. Okay, finally we have our last set of numbers, which was x equals 11 and y equals 3. So 2 times 11 minus 3 plus 6. 2 times 11 is 22 minus 3 plus 6. 22 minus 3 is 19, and plus 6 is 25. Now we're going to be moving on to evaluating equations with variables. So what does this exactly mean? So equations are like expressions, except they have an equal sign. And the equal sign means that both sides to the right of the equal sign and to the left of the equal signs are equal. So we need to find the value of x, which proves that statement. So to prove this statement, we need to isolate the variable and get all the numbers on one side. The first step in doing this is to subtract the 8 on both sides. So we're going to do minus 8 minus 8. So that's going to equal x plus 0 equals 2, which is ultimately x equals 2. So by subtracting the 8 on both sides, we got rid of all the numerical values and isolated the variable. So we found out what x is, the value of x. And to check our answer, we're going to plug into back to the equation. So 2 plus 8 equals 10, and we know that 10 is equal to 10. So this is correct. Let's try another one. X plus 6 is equal to 18. We need to isolate the x, so we subtract 6 from both sides. And that's x equals 12. And if you want to double check, you just plug in the x back to the original equation. So 12 plus 6 equals 18, and 18 is equal to 18. How about x minus 4 equals 6? This time we have to add 4 to both sides to make this equal to 0. So that would be x equals 10. And to check, we do 10 minus 4, 6. 6 is equal to 6. Let's do x plus 5 is equal to 12. So we subtract 5 on both sides. So 12 minus 5 is equal to 7. So 7 plus 5 is equal to 12, and that is 12 equals to 12. How about 10 minus 8? 10 minus x equals 8. So this time the x is negative, and we want a positive variable. So we're going to add x on both sides first. So that's just going to equal 10 equals 8 plus x. And now since we want to isolate the variable, we're going to subtract 8 from both sides. So that's going to be 2 equals x, which is the same thing as x equals 2 because of the commutative property. So to check, we do 10 minus 2 equals 8, and 8 is equal to 8. Let's try some of these with multiplication. So 4x equals 12. So the first thing we want to do here is isolate the variable, obviously, but there is a 4 right next to the x, which I explained earlier means multiplication. That means we need to divide on both sides to get rid of the coefficient of x. Coefficient, if you don't know, just means the number right in front of the x. So we're going to divide by 4 on both sides. So 4x divided by 4, and then 12 divided by 4, which is going to be 1x equals 3. And you usually don't write the 1 in front of the x, it's just assumed that it is there, so x is equal to 3. And we're going to check this by plugging back the number into the original equation. So 4 times 3 is equal to 12, and that is a correct statement. Let's do another one. 3x equals 9. We're going to divide by 3 on both sides to isolate the x, and that's going to equal 9 divided by 3, which is 3. And to check, 3 times 3 equals 9. 9 equals 3. 9 equals 9, sorry. Now let's try with more than one operation. So 13x plus 7 equals 12. So first let's get what we can get rid of first. The easiest is subtracting 7 on both sides. So that's just going to be 12 minus 7, which is 5. We're going to divide 13 on both sides to get the x completely alone, and that's going to be 5 over 13. How about 5x equals 20? Divide by 5 on both sides. 20 divided by 5 is 4, so x equals 4. Let's do 6 plus 7x equals 13. So I'm going to subtract by 6 on both sides. That's going to be 7x equals 7. So we divide by 7 on both sides. 7 divided by 7 is 1, so x is equal to 1. Now let's try 16 minus 2x equals 4. So in this one, we see that the coefficient of x is negative. So to get x positive, we're going to move it to the other side of the equation. So let's add 2x on both sides. And that's going to be 16 equals 4 plus 2x. Now we're going to subtract 4 on both sides. 16 minus 4 is 12 equals 2x. Divide by 2 on both sides. 12 divided by 2 is equal to 6. So x is equal to 6. How about 64 equals 8x plus 8? First thing we do is subtract 8 on both sides. 64 minus 8 is equal to equals 8x. And then we're going to divide by 8 on both sides. And 56 divided by 8 is equal to 7. So x is equal to 7. Let's try 20x minus 6 equals negative 20. We're going to add 6 on both sides, which will get us to negative 14. And so we're going to divide by 20. So x is equal to negative 14 over 20, which can be simplified into negative 7 over 10. Let's try 2x plus 13 equals 13. First step is to subtract 13 on both sides, which will get us to 2x equals 0, because 13 minus 13 is equal to 0. Now all we have to do is divide by 2 on each side. So 2x divided by 2 and 0 divided by 2. So x is just equal to 0 because 0 divided by anything is equal to 0. Now we're going to apply our knowledge of variables and expressions and equations today to the concept of PEMDAS. So if we had an expression that said 2x divided by 3 plus 5 plus 7 times 4x, and then it said evaluate when x is equal to 3, we have to plug in 3 for every x that we see in this expression. So this is going to be looking like 2 times 3 divided by 3 plus 5 plus 7 times 4 times 3. And I just use the dot here to represent multiplication so that we don't get confused with x and the actual variable. So as always, we start off with the parentheses. And in the parentheses, I see two different operations, which is multiplication and so of course we do the multiplication first. So we do 5 plus 7 times 4 times 3, which is 12. And then we still have the parentheses. So we do 7 times 12, which is 84. And then we do 5 plus 84, which is 89. 2 times 3 is equal to 6. 6 divided by 3 is equal to 2, plus 89 is equal to 91. And that is our final answer. Let's do one more problem like this. So, evaluate this expression for when x is equal to 6. So we start off with the parentheses. Oh, sorry, I forgot to mention, you have to plug in 6 for x first. And then we do the parentheses, which is 6 minus 3, and that's simply just 3. And then we do 4 times 3 first because it comes over subtraction. So 4 times 3 is 12. And then minus 20 is negative 8. So our final answer is negative 8. So that's all we have for today. I hope you learned and understand how to evaluate variables for expressions and equations, and we'll see you again in our next lesson. Make sure to comment down below if you have any questions or feedback for this video and for future lessons. Thank you.